Hello guys, in this video we are going to discuss the solution of the problem maximum difference. So let us look at the problem statement. The problem statement says given an integer array ARR of integers, the task is to find the maximum absolute difference between the nearest left smaller element and the nearest right smaller element of every element in array ARR. If for any component of the array the nearest smaller element doesn't exist, then consider it as 0. So let us try to understand the problem statement with the help of an example. So let us say this is the array which is given to us and we want to find out the maximum absolute difference between left smaller and right smaller. In order to find out the maximum difference between left smaller and right smaller, let us first populate the values of left smaller and right smaller. So in this, as you can see, there is no element which is smaller than 2 in the left side of the array, because of which this will be 0. For the second element, 2 is the smaller, so we are going to place 2 over here. For 8, 4 is the nearest smaller, so 4. For 7, the nearest smaller is 4, so 4. Again, for 7, the nearest smaller is 4, so 4. For 9, the nearest smaller is 7, and for 3, the nearest smaller is 2. And in this way, we have populated the left smaller for the array. Similarly, let us populate the value for right smaller. So for right smaller, we are going to populate it from the right side of the array. As we can see, there is no smaller element towards the right of 3, because of which this will be 0. For 9, the smallest element towards the right is 3. For 7, again 3. For 8, the nearest smaller is 7. For 4, the nearest smaller is 3. And for 2, since there isn't exist a nearest smaller to in the right part of the array, because of which this will be 0. And once we have this ls and rs array with us, all we have to do is we have to take the individual diff and the absolute diff. So this will be 0. The absolute diff is 1. It is 3, 1, 1, 3, and 2. And from this lot, we have to find the maximum value. Since the maximum value is 3, and that is what we are going to return. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to find the smallest element in the left part of the array. So let us see how we will be able to find it out. So let's start with the same example. So let us say this is the array which is given to us. What we are going to do is we are going to maintain a stack, and initially the value of a stack is empty. And then we are going to have our ls array. The idea behind forming a stack is to store the nearest smallest element on the top of the stack. So let us see how we will be able to maintain it, and using this stack how we will be able to populate our left smallest array. So let us iterate on the elements. Since 2 is the first element, so the stack is empty, and since there isn't exist any element which is smaller than 2 towards the left part of the array, because of which we are going to mark it as 0. And once we have marked it as 0, we are going to push this element onto our stack. So the nearest smallest element so far is 2, and that is what we are maintaining it on our stack. So the next element is 4, and for next element what we are going to do is we are going to compare it with the stack. If let us say the stack element is greater than the current element, then we are going to pop those elements, because those elements are greater than the current element, and our objective is to find the smallest element. Since in this case 4 is greater than 2, so that simply means 2 is the smallest element, because of which we are going to update our ls array by 2, and then we are going to push 4 onto our stack. Then the next element is 8. Again 8 is greater than 4. That simply means 4 is the nearest element, because of which we are going to put 4 over here, and then we are going to update 8 onto our stack. Now the next element is 7, and since 7 is lesser than 8, that simply means 8 is not the smallest element, because of which we are going to pop it from our stack. Now the next element on the stack is 4, and since 4 is smaller than 7, so this is the nearest smaller element, and we are going to push 4 onto our stack. Then we are going to push 7 on our stack. Now again, the next element is 7. Since 7 is not less than the top of the stack, because of which we are going to push this 7 out of our stack. The next element onto our stack is 4, and since 4 is less than 7, because of which we are going to populate our ls array by 4, and then we are going to push this 7 onto our stack. Now the next element is 9, and since 7 is less than 9, because of which we are going to push 7 over here, and we are going to push 9 onto our stack. Then the next element is 3. Now since 9 is greater than 3, because of which we'll pop this. Similarly 7 is greater than 3, so we are going to pop this. 4 is greater than 3, because of which we are going to pop it. Now 2 is the element which is smaller than 3, because of which we are going to push 2 onto this ls array. And in this way we will be able to update our ls array. Now in order to update our rs array, what we are going to do is we are going to reverse our current array. So ARR will become 3977842. And once we have reversed the array, all we have to do is apply the same logic in order to populate our RS array. So let us apply the same logic in order to get our RS array. Again, we will have our stack, and since there isn't any element which is less than 3 towards the left part of the subarray, because of which this value will be 0, and then we are going to push 3 onto our stack. For 9, since there exists 3 which is less than 9, because of which 3 will be over here, and then we are going to push 9 onto our stack. For 7, since 9 is greater than 7, so we are going to pop it, and then since 3 is smaller than 7, because of which we are going to push 3 over here, and we are going to push 7 onto our stack. For 7, since 7 is not less than 7, because of which we are going to pop it from our stack. And since 3 is less than 7, we are going to push it onto our RS array. And then as usual, we are going to push 7 onto our stack. Then the next element is 8. Since 7 is less than 8, because of which we are going to mark it as 7 over here. And then we are going to push 8 onto our stack. The next element is 4. Since 8 is greater than 4, similarly 7 is greater than 4, we are going to pop this. And we are going to have 3 over here. And for 2, since 3 is greater than 2, we are going to pop it from our stack, and there isn't exist any element onto our stack which is less than 2, because of which this will be 0. And in this way, we have populated our RS array. The only thing over here, folks, if you see, this RS array is the reverse of the RS array which we obtained. So in order to tackle this, all we have to do is, when we compute the diff between ls and rs, all we have to do is we have to take the first element from ls and the last element from rs. Similarly, when I'll be taking this second element from ls, then I'll be taking the second last element from rs in order to tackle that. And in that way, I'll be able to compute the maximum absolute difference, and that is what I'm going to return. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find out max diff, and an array is given to us. So the first thing which we are going to do is we are going to populate our ls array, and the ls array will be populated as left smaller. And for this, ARR is our input. Now what we are going to do is we are going to reverse array ARR, and then we are going to populate our RS array, which is again left smaller of ARR array. And please note, this ARR array is a reversed array. Now all we have to do is, once we have our ls and rs array, we have to compute the maximum diff. So let us say our answer equals to -1, and let's compute the maximum diff. So for I in range of n, and let's say n is equals to len of array, and then let's compute the diff. So if absolute difference between ls of I and the last element of rs, so n -1 minus I, if the absolute difference is greater than answer, then answer is equals to absolute difference. So absolute difference between ls of I minus rs of n -1 minus I, and then towards the end we will just return our answer. Now let us look at this left smaller function. So let us say we want to find our left smaller, an array is given to us. The first thing is we need a stack over here. So let's have a stack and then our ls array, and the size of this ls array is n, where n is equals to len of array. And then we are going to iterate on all elements of array. So for element in ARR, so as we have discussed in our explanation section, we are going to pop all the elements from the stack which is greater than the current element. So for that, let us do this while stack is not empty and the top element of a stack is greater than or equals to current element. If that is the case, then we are going to pop the element from the stack, and after popping the element from the stack, let us check if stack is not empty. If stack is not empty, then the nearest smallest element is on the top of the array. So ls of I is s of top, and let's say I equals to 0. Otherwise, if let us say stack is empty, in which case there isn't exist any element which is less than the current element, because of which we are going to mark it as 0. And then as usual, we will just increase our I and we will push the current element onto our stack. And towards the end, we are going to return ls. And in this way, we will be able to compute the maximum difference. So that's the pseudocode, folks. Now let us see how we have implemented this in C++. So the C++ implementation is pretty much the same, folks. Over here, we are populating our ls array. Then we are reversing our given array, and then we are computing our rs array. Once we have our rs array, all we are doing is we are iterating on the elements of the array, and we are computing the absolute difference between ls of I and rs of n minus 1 minus I. If this difference is greater, then this is our answer, and then towards the end we are returning our answer. Now let us look at the left smaller function. In the left smaller function, we are initializing our ls array, and then we are taking a stack, and then we are iterating on all the elements of the array. If the stack is not empty and the current top element of the stack is greater than the current element, then we are popping those elements from the stack. If after doing so, stack is not empty, then ls of I is equals to s of top. Otherwise, ls of I equals to 0. And then we are pushing the current element onto our stack. And then towards the end, we are returning ls. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.